Hi everyone. In this lesson, we'll refactor some code to be simpler by calling the map method. For example, here's a method named f that adds 1 to each element of an array. So we'll start on line 7 here, a equals 3, 2, 1, call the f method, which will initialize the variable b with an empty array, and then for each element of a, 3, 2, and 1, it will add 1 plus that to the b variable. Finally, we'll return b. Let's see that. So set a to 3, 2, 1, set b to empty, add 4, 3, 2 to b, and finally return b so we can print it out. So now let's refactor this code to use map. So just like the each method, map will run a block once for each element. So let's change each on line 3 to map here. Now unlike each, map pays attention to the block's return value. So we don't have to call push inside the block. We'll just return the expression and map will push each one for us. So I can get rid of the b.push. Now you might wonder, how does this x plus 1 even get connected to b then if we want to change the b variable? Where's the b? Well, map itself is going to return a useful value, unlike each. So I can save the result to b by writing b equals. When I run it, you'll see it does the same thing. So you might wonder, why use map if it just makes you have to think about return values? Well, instead of taking 3 steps to set b to what we want, we can now refactor to use less code. We can even eliminate this line too, because we already assigned map will create the array for us. We can even eliminate this b variable altogether because we're just creating it and returning it, and the last line of the method will just return it for us. So we don't need a b variable anymore. And in fact, we don't even need this f method anymore. We could move this expression all over to the bottom directly and just call map right there, instead of defining this method. You'll see it still works. So this style of programming can be very powerful and concise.